Hi, my name is Brittany Daltney, and this is my informative speech. Technology has become a vital part of everyday life. Every day we use phones, computers, televisions, and cars. Technology affects everyone. As children, we grew accustomed to all technology had to offer. Now it is possible for people to directly interact with these gadgets by using motion sense technology. But how does motion sense technology really work? Over the next few minutes, you will have a better understanding of motion sensors and how they work. According to InventSense, there are 4 types of motion sensors that directly impact the latest gadgets. These are G-sensors, gyroscopes, magnetic sensors, and barometric pressure sensors. I will begin demonstrating how G-sensors, also known as accelerometers, work. G-sensors are used to measure acceleration forces. According to Dimension Engineering, there are 2 types of acceleration forces. Static forces determine the tilt of the device with respect to the Earth's magnetic field. An example of static force is tilting your iPhone from side to side. This movement will change the screen from portrait to landscape format. Dynamic forces determine the direction in which the device is moving. These G-sensors work by measuring the acceleration forces as they move across microscopic crystal structures. Think of bare feet on a carpet. As they are moving, imagine the carpet is microscopic crystal structures. The faster you move your feet, the more static is generated. The forces from this movement are measured in static charge. G-sensors detect these static charges and measure the changes with accuracy. They also measure vibrations. This allows us to measure seismic activity during and after an earthquake. The second fundamental motion sensor is the gyroscope. Gyroscopes are used to track the rotation of moving objects around one or more axes. Gyroscopes measure what is known as the angular rate of rotation. They defy gravity, therefore making them independent from external forces. Gyro compasses replace traditional compasses due to the Earth's gravitational pull. In recent times, gyroscopes have been used to stabilize aircraft and spacecraft and are now used in the latest technology such as the iPhone 4 and 5. MEMS, known as the micro-electro-mechanical systems, are a newer, smaller version of gyroscopes. These can be placed in smaller objects and allow for more versatile use. Next, magnetic sensors are used as navigational tools in the latest software. One is now able to download maps and use compasses on your phone with the blink of an eye. Due to the weakness of the magnetic field, it is common for one to calibrate this software many times. This can be caused by interference from electronics and building equipment, enabling the sensor to be impacted by surrounding conditions. An example of this interference would be placing a magnet next to a compass, causing the needle to spin. This is due to the magnetic field of the Earth being weaker than the field of the magnet itself. Last, barometric pressure sensors monitor the change in atmospheric pressure and allow us to measure relative and absolute altitude. There are 5 types of pressure sensors. These are absolute, gauge, differential, sealed, and vacuum. Absolute sensors monitor atmospheric pressure. This is useful when determining weather conditions. Gauge pressure is used to tell the amount of pressure in pipes, cylinders, and tires. Differential pressure sensors measure the pressure between 2 points. An example of this pressure is measuring the strength of a steel bar by finding the difference between point A and point B on the bar. This difference would indicate the strength of the bar. Steel pressure sensors are used to find the pressure of relation to the sea level pressure. Finally, vacuum pressure sensors are used to measure pressure less than 76 millimeters of mercury, which is normal atmospheric pressure. Motion sensing technology has become important to advances in everything from phones to cars. The application of technology has opened up incredible opportunities in multiple industries. The possibility for development of new technologies involving just these 4 motion sensors are endless. The 4 fundamental motion sensing technologies are G-sensors, gyroscopes, magnetic sensors, and barometric pressure sensors evolve all the time. In conclusion, motion sensing technology is imperative in our day-to-day lives. Thank you.